Alright, so we have our little setup right here. It's called a Ruben's tube. What it helps us do is, it's named after Ruben, who was a scientist, and he discovered a way that we can visualize sound waves. And the way it works is it uses the compression wave that a sound wave travels through to produce a transverse wave in the flames. We go ahead and light this up. We'll kind of see. So there's a bunch of holes drilled across the top. The flames are coming up through using propane. And if we generate a tone through this, we should be able to see how those waves affect us. This is about 350 hertz. And you kind of see the waves start to form. We turn it up just a little bit. Just over 400 hertz, we can see that we have a peak here, a peak here, a peak here, and a peak here. So the way we do this is the distance between peak and peak. That's the wavelength of the sound wave. And as we increase the frequency, that should decrease the distance between the peaks. So if I increase this frequency, you can see that the peaks get closer. So now you can see that this distance is much smaller, about a foot compared to about a foot and a half. Also, the amplitude is controlled by how much energy that is traveling through the sound wave. So if I turn the amplitude down, we should expect the wave peak to come closer to the tube. Then if we increase it, we'll see that it gets really big. And then the cool thing about the Ruben's tube is we can play music through it, and it'll let us visualize that music. So we can edit, clip this, and then start with the song name.
Mm-hmm.
So this song is For Elise by Beethoven, and it gives us a really nice representation of what kind of the visualization of the music. The nice thing about the piano music is it gives us a pure tone to represent in the tube, and the tube will pick up those pure tones in the form of the wave.